Hello everyone and welcome to today's video. This is the first video of the first chapter of this series, wherein I'm going to show you how to build a computer in Minecraft. Quick disclaimer, this will not be the fastest computer in the world, and we will not be able to play 3D Minecraft on it. Just saying. So, how will this series work? In the first chapter, I'm gonna explain everything we need to know to build our computer. In the second chapter, we're actually going to build one, and I will explain some redstone mechanics in the process. And in the third and last chapter, we are gonna learn how we can program our computer and put some games on it, because that's fun. Being the first video of the first chapter of the series about computers, we of course can't go over anything else than the classic binary system. To understand the binary system, we will first need to take a look at this decimal system, because it's very similar. If we divide our number 9273 up into these parts, you can see that they follow a pretty obvious pattern, because we use decimal system a lot, so this will look pretty dumb, but it's basically the way binary works, and almost every counting system in the world, except from counting systems like the Roman did with their letters. But basically how it works, you take 10 in decimal system, you take 10 and you do it to the power of the column you're in. So the first column is the column of 3, and you multiply 3 by 10 to the power of 0. That's 1, so 3 times 1 equals 3. That's the bottom line. We do the same for 7. 7 is in column number 1. 3 was column number 0. 7 column number 1. We do 10 to the power of 1 is 10. So we get to 70. 10 to the power of 2, because 2 is in the second column, equals 100. So we get 200. And the same goes for 9. 10 to the power of 3 equals 1000. So we get 9000. If we count all these separate numbers, if we add them all up, we will get 9000 plus 200 plus 70 plus 3 equals 9273. And we can do the exact same thing for binary, like I will show you right now. Again, here I filled in the number 0101 in our middle row. And unlike the decimal system, which uses powers of 10, we will fill in the powers of 2, being 8, 4, 2, and 1. And then we multiply our numbers. So in the 0th column, we do 1 times 1 equals to 1. In the first, we do the same, but here we have times 0, so we can just ignore it. And the second column equals 4, and the last equals 0. We will then add up all of this, and we will see that 0101 equals to 5 in binary. But there is a better way to do this. These zeros in our number, we already ignored them, but we can also skip the multiplying by 1 part and just writing our column number. Like when we had to multiply by 1 and 4, we could have just taken those numbers, as they didn't change during the multiplication. This is a very unique property of the binary system, along with a few others. So the next time we come along a number, we just take our power 2 and look if there is a 1 or a 0. And when there is a 0, we add it up to our final sum. Now I'm going to show you how you convert a decimal number into a binary one in 8 steps. The first step is we will take our highest power of 2 and we will subtract it from our decimal number. So we will check 16, that's a power of 2, that's greater than 10. Before we get to 16, we will get to 8. 8 is less than 10, so our highest power or factor we can use is 8. And then we will add 1 to our columns from the previous slides. After that, we will subtract our highest factor from 10. In this case, we will get 2. And then we will repeat step 4 and 5 for a while. Because the step 4 is 2 minus our next factor. So before we get to 8, we have 4. 2 minus 4 equals a negative number, so we will add a 0 to our column. Then we will check for the factor before 4. That's, in this case, 2. 2 minus 2 equals 0, and that's acceptable. In this case, it will even be the ending of our number, as we will add a 1 to our number, so we now have 101. And then we have one final step. Because we had 0, we will just continue to add more zeros to our number until we get to 1. So before 2 we get 1, we immediately are there, so we get 1010. And that's how you convert a number to binary. If you want to extend this by greater numbers, you will see this still works, and you can even use it more efficiently, because if you go over all these 8 steps just to know what 10 is in binary, you are really wasting your time. If you work more and more with binary, you will see that you will know some small numbers like 10. You can do that really fast in your head. Just 8 plus 2 equals 10. All the factors of 2 we had. And then you can just, you just need to make sure you have the right amount of zeros after your last 1. And you can check that by going through the previous slides and other methods. But that's how you convert decimal to binary. That was everything for this video. In the next one, I will go over addition and subtraction in binary. I hope you've learned something from this video. I think it's necessary to know some basics like binary before we can get into the real stuff about the inner workings of a computer. But if you have any questions, please ask in the comments. I will answer all of them, and if you're really lost, then it's probably my bad. I'm not a teacher, and I'm just trying to explain this the way I think will help you in the future. There are lots of different YouTubers out there that can explain this much better than I, but I would like to put everything I've learned into one series, so you could theoretically just watch one and build a computer out of it. I hope you've enjoyed, and I will see you in the next video. Bye!